soon as it started.
Yeah.
Yeah, it's
Hello.
recording.
Hello. This is Team JHB21 of 2024. The team consists of Samgelo Kambule, myself, Ntlankala, Rahaman Kazembe, Kilolo Makau, and Dennis Pori. Next slide, please. So the presentation overview will be the demonstration of our whole brownfields project that was improved by the team. It consists of the project outline, the breakdown of what Team JHB21 was able to do and what could have been improved. It also consists of feature overview, which is the top 3 challenges and our proudest moments, the tools that we used in the making of the project, and the demonstration of the code itself. So for the first iteration, we were supposed to set up the task board in GitLab for tracking our backlog. We also were tasked to write acceptance tests and make sure they pass against our server and the reference server. We were also tasked to build scripts for the code compilation, testing, and packaging. Lastly, we were tasked to perform a code analysis to check the health of our code, the code provided by the school. For the second iteration, we continued writing acceptance tests and updated the backlog. We did another code analysis to check if the code has improved with the improvements we've made or not, and also implement the pipeline and also create a Docker image. For the third iteration, we had to learn how to maneuver around the relations of the relational database concept, which is SQL itself, how to create a database, and so on. We also had to implement it um, into being able to save the world in this case and being able to restore it. For the fourth iteration, we had to apply architectural patterns for separation of concerns. We also had to implement a web API for robot worlds and integrate an ORM that won't disturb the database. So for the breakdown of Team JHB21's brownfields, what we were able to do was to get the issues done on GitLab task board. We were also able to refactor the robot world server so that our acceptance tests pass against the reference server and our server. We were able to build uh, the pipeline and also create a Docker image so that we are able to Dockerize the whole process. We worked on the database, which assisted in saving and restoring the world. We also worked on the ORM. Excuse the spelling there. I made a mistake. And we also worked on making improvements on the code base. What was not done was the purge command and the GUI. which was not a necessity. It was just gonna be a bonus. And what we could have improved is the code base itself. We could have worked on it better. Yeah, we could have made it even better. For the feature overview, we have our top three challenges, which was altering the server so that our acceptance tests pass against it. Uh, there was uh, loss of work due to merge conflicts, but we figured that out and made it work. Uh, lack of expertise. There was a lot to learn in this whole project, but we made it work. We learned on the job and did the work. Our team's proudest moments were the fact that everyone took accountability in everything. We improved the improvement in our work ethics. We were able to work as a team without any conflicts, which I'm happy with. Uh, Everyone was able to step up whenever they saw that the next person was lacking and assisted. So we did a lot of code pairing. Um, we also worked successfully in one branch without losing any work, although we had to do a lot of reverting, but we were able to retrieve work. And we have a functional demo. We got most of the things done. So thank you guys. I'm proud of you. So we are going to go to the Brownfields demo now, which consists of um, improvements that could have been made. I'm sure we'll just do it lastly, based on the code scene. Uh, the acceptance test will take you through the acceptance test, the builds, and the database, and also the ORM. So we'll move on shortly to the brownfield itself. And also, I forgot to mention, we also have to ha, we also have to go through GitLab for the tracking. Right. The tools we used was IntelliJ
Right. Thank you so
and
much. I'm getting
sure.
Tlantla, you are breaking. Are you still with us?
I'm still with you guys. I'm not sure if you can clearly.
Yeah, the tools we used were IntelliJ and VS Code for coding. We also used GitLab for version control, Maven for building, Slack for communication, and also WhatsApp because it's not every time that Slack works. It was quite faulty. We also used Google Meets for our daily stand ups whenever others were not present at campus. We used Docker to create a Docker package and a Docker image. We also used CodeScene to consistently check the health of our project. We used JUnit for writing tests, Postman, and curl for the for the build in the database. No, not for the build. Um, for the ORM and the database for sure. Yeah,
For testing the H.
yeah, and testing. I can't really see what's at the back. My site is not well. We also I can't see, guys. Yeah, thank you. We can move on to GitLab. Over to you, Ntlantla.
Right. Thank you so much for passing the mic on. I'm just gonna ask Rahaman to stop presenting so that I can present. So I'm just gonna take you through the GitLab, which is what we were using for version control. So this made it
Mhm.
easy for us to keep track of our code, the changes, and then so that we don't really do a lot of redundant things and we actually do what it is that we are supposed to do. Right? So
Yeah.
just a moment as I share. Does everyone see my screen?
Not yet.
No, not yet.
Mm.
Let me know if you do. Let me know if you do.
Yeah, it's
We
loading.
don't yet. It's still loading.
Can you see it yet?
It's
Not
loading.
yet.
Oh, okay. Okay, so what I'm gonna do is to show you the issue board. So the structure that we used was every time we have an issue that we're supposed to do. Most of the issues that we are creating were just for the acceptance test that we are supposed to do based on the iteration that we are going through. So with each iteration, we would open an issue and then whoever is assigned to the issue works on it, and then as soon as they are assigned their sole responsibility is to move it over to close. So okay, with that being said, let's just move these ones over to close. I don't know if you guys can see me doing this,
Yes, we can.
right?
Mhm.
Right, so all of these, they are done. Robots not launching in the world. Are the robots launching in the world?
The yes, they are.
Okay, no problem. Okay, can you guys see my screen yet?
Yes, we can.
Yes.
Okay, so now these are the issues that we had to do, and then last iteration, the issue that we are supposed to do was to save and restore many worlds. We're supposed to save the world to a database, and we're supposed to restore the world. What those commands do is that when a player enters the world and then they play and then they want to enter it or use it for another time, they can be able to use it with the same world, same obstacles, and the same robots in the same world. Same way as you can, if you can think of PlayStation, every time you quit a game or you pause it, or it goes back to the same place that we are on. So this is one of the things that databases make it less easy for handling and accessing information, as opposed to using a JSON file, which is just gonna store it temporarily. So yes, I'm just gonna show the contributor analysis um, so that you can see our spread of contributions, right? Is everyone still with me?
Yes, we are.
Okay. All right, so it's still loading, and then after that, we're gonna do the demo, and we should be okay. Okay, okay. So as you can see, these are the previous contributions from the previous people who were working on the code. So how Brownfield is set up is that they give you existing code and then you just have to fix the code, whatever it is that's breaking without touching the actual code. And then also make improvements without touching the actual code. So we're experiencing some problems where we fix something and a lot of other things break, but we're able to break through that by God's grace, and this has taught us a lot um, through these things. And then with contributor analysis, thing is sometimes we access from home and we access from school, so it's gonna seem like more than one people were contributing, but it's still the same person from different computers, right? So I'll take it over to Rahman um, to give us the demo. I'm gonna stop presenting now.
Okay. Okay. Thank you so much. Let me share my screen. I'm gonna click on present, share screen. Mm. Hello.
Hello, how are you?
Can you guys see my screen?
Yes, we can.
Um, Pardon me for using VS Code, but for this demo, I'll be using VS Code, and the reason being, um, something went wrong with my IntelliJ. Yeah, and fixing it will. I'm not in a position where I can fix it right now, so I'll just use VS Code to demo the project. So the iteration was divided into four iterations, and for each iteration we had to implement certain aspects. For the first iteration we had to write some acceptance tests, and we
Mm-hmm.
have the code. It's code right here, under test, under source, test,
It's under
and
acceptance.
on the reference acceptance. And so this is the code for the acceptance test. So we've got tests for the um we've got tests for checking if our database can connect. We've got tests for the forward commands. We have tests for launching robots, tests for test to see what happens when our robot looks around, test for restoring a saved world, test for saving the world. Right, those are our acceptance tests. So acceptance tests, in essence, they are tests that we write before coding our program, and they essentially tell us what to how the fulfilling user stories, right? So a user will be like, I want my application to work the certain way, and we write those acceptance tests to see if our program meets the requirements of that user. um and then after for the second iteration we had to um pardon, give me a second. For the second iteration we had to look into um sorry about this, my network. Yeah, for the second iteration we had to build pipelines, also write user stories, do some code analysis and packaging for deployment. So that's where my demo will start. So what I'll do is we had to write this make file. Where is the make? There it is. So this is a make file, which is a packaging file. So we wrote some commands that will help us build a tool, and I'm gonna just run it once here to demo to you. Um, so I'm gonna run make all. So it's gonna run all the commands in our make. So essentially, what our make all does, it it compiles, it runs the test to see if the test passes, and then it packages the file and then builds it into a jar file, which is a runnable instance of the app. So I'm gonna enter this. Oh, my PC is freezing. Yeah,
So it's probably the network.
yeah. As you can see, it is successfully built, and the build file is actually packaged and stored in our target folder, right? And moving on from
Go.
there,
That's
the next thing,
fine.
yeah, moving on from there, we had to also uh, make some code changes. And for this iteration, those code changes were, oh my goodness, my network is so bad. I can't even view my notes.
Okay, just to jump in there, I'm not sure if we mentioned this, but for the first iteration, we were given a reference server, and then we had to write acceptance tests that had to pass against the reference server. So that became sort of a blueprint that we had to use to basically make sure that the test that we write pass against our own server. It was the same for the second iteration. We were provided with a reference server, and our acceptance test had to pass against it. So it's been an uphill battle from reference server where your hand is being held and everything, and then you have to make things work now. And it seems like every button you touch breaks everything. But I must say I'm very proud of where we've come from. These past 8 weeks have been nothing short of amazing.
Mm.
So yes, give yourselves a pat on the back. This takes me back to when we started Python. For some of us, it was the first time ever seeing code, and the people that we've grown to be is really inspirational. Rahman, are you winning?
Yeah, I'm just gonna change the screen now just to show. I'm not gonna demo the actual pipeline process, but I'll just show you the one that the latest push that we pushed and then it passed. The reason being of the network. Let me just change the
Okay.
screen. Um,
Are you gonna stop sharing and then share the other screen?
yes, yes,
Yes.
yes. That's what I'm gonna do. Share screen,
Okay.
and now pipelines, and then I'm gonna share this. Can you see my screen?
Rahman,
Yeah.
can you also break down what pipelines are and what is their function, just for someone who
Oh,
maybe doesn't know?
yeah. Okay. So pipelines are a part of DevOps. So what happens is there's something called CI/CD, continuous integration and continuous delivery. So what we want is when we write tests for our application, this is the way we expect our app to work. And so every time when we make code changes and we wanna upload them to our version control tool, which is GitLab. We don't want the new code to break what was already working. So what CI/CD does, it blocks your code from being uploaded onto the version control if it causes the previous test to pass. So yeah, that's what it does. So that's where hence the continuous delivery, right? Continuous integration, continuous delivery. So every time you make code changes, you push them to GitLab. What happens is it will run those tests and see, okay, if those tests pass, then it will allow the test to go through. It will allow the code changes to go through, and if they don't, then it prevents them from going through. So that's what CI/CD is about. So moving on, the following iteration we had to introduce relational databases and introduction to SQL, which was one of the funnest parts of the project. So the code for this one is we kept it under um, data, right? So if you look at here in the database command controller, you'll see we have some SQL code um, using JDBC, which is the Java driver for connecting to databases. The database we're using was SQLite, and I can demo to you some of. So this is some of the database code here. So let me just run a short demo of how it works, right? So what I'm going to do, I am going to run the server, and the server exists down here. Click on server. So, and here we go. So the server is running, right? So I'm going to run dump just to show you the obstacles that we have. So we have a couple of obstacles right here, right? So now I already have an existing world. This is our database. This is just a tool that I've used to view our database. It's an VS Code extension. So I'm gonna click on worlds so we can see all the worlds that we have in our database. So if you look at here, you can see all the worlds that we have in our database. So I have Dell, Africa. So these
Rahman,
are all the.
are you demoing from GitLab, or
Oh, sorry.
because I can only see your GitLab screen here.
Oh, okay. My bad. Oof.
Sorry, sir, it's
Let me see.
fine. It happens to the best of us. Yeah,
Uh,
you might have to say everything that you said with the SQL.
okay. Cool. Cool.
Oh
Cool.
my gosh.
Can you see my screen now?
Not yet.
I'll add it to the stage now. Yes, it's just added.
Can you see?
Yes.
Yes, yes, we
Okay.
can.
Okay, cool. So what I was saying was that we have our database code, and it uses JDBC to connect to the database. And that code is stored here in the command controller. So we have our data access objects, data access interfaces. This is where we create like a model of the world, and then we use that model to store and retrieve the world from the database. This is the database. This is the SQL code that we use. We're creating. I'm not gonna go into too technical for the sake of the video, but I'm just gonna demo how it works, right? So, first and foremost, I'm going to run our server code. Um, this is our server. Blah 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 blah. Okay, there is it. So I'm gonna run the server code, and this is our server code running. Um, since our server code is running, I'm gonna run the dump command. So what the dump command does, it just shows us all the obstacles, what the state of our world essentially. So now it's telling us, okay, we have obstacles in these places in our world. So we can retrieve a world that was saved. So I have previously saved worlds in our database. So if I come here and click here, this is an extension that allows you to view your database. So this is the table for the worlds. So these are all the worlds that I stored. So I'm gonna just go with Hull. I'll try and retrieve the worlds in Hull. I want you to keep notice of the obstacles here and their position. Let's say, for instance, the first one is minus 198, right? The X position. So I'm gonna say restore Hull. So if I run dump again, um, yeah, it shows different data. Moving on, the other thing we had to do for the previous iteration was to introduce the data access object, although it was more of a suggestion and it was more enforced in the fourth iteration. So the data access object is, in our case, it's this one. So it has code to add our world model into our database with its obstacles and to retrieve our world model into the database, right? So this is the data
Mm.
access object model. And then moving
Mm-hmm.
All
on to
right.
the last.
So, mm,
Okay. Go on, Tlantla.
no, I just wanted to ask about the web API ORM that Samgel was talking about. Are you gonna get to that?
Yeah, I'm gonna get to it briefly.
Mm,
The API and ORM. Thank you.
mm,
So moving on. So under this web directory or folder, we have code that
mm,
our API code, right? So what
mm,
happens is if I open our web server, you can see we have paths like as in world slash API handler. So slash world. If we go, if I search, okay, let me just demo it. It's much better than going into the technical stuff. I'll run this code here, this server, and I'm gonna use curl to demo this. Mm, yeah, so we have Javelin running. So let's try and retrieve an existing world, HAL, for example. So I'm gonna say um yes, this I'm gonna use this command. So curl request dot get. Well, I want you to pay attention to this HAL here. So this is the name of a world that we have in our database, as I showed earlier on. And if I hit enter and we retrieve some JSON, so this JSON here, it tells us, okay, the name of our world is HAL, and then it has obstacles and a list. So the list is a list of all the obstacles that are present in our world. So this slash HAL, where do I get it from? I get it from right here. This slash world comes with slash. Here I said slash world, right? So then after slash world, we put slash and the name of the world that we want to retrieve from our database, provided that name exists. And one more thing that we can do with our API is we can just search for world and see what happens. So when you search for world, it will retrieve all the worlds that exist in our database. For example, we have Malawi, we have Ghana, we have JJ, we have KKK. And if I go back here, you'll notice that we have all of those worlds here. So it retrieves all the worlds. So slash world just receive of the world. If you say slash world and then the name of the world, it will retrieve that particular world. So we can also save the world in our database. So if we wanted to save our world, we have to run the server yet again. And you guys have, where's the server? Sorry about that. We're gonna run. So if I run save, save, I don't know what will I call this within code. And a new world has been inserted into our database. So if I come here, refresh the database, come here, we should expect to see a within code added. So if I scroll down, the within code has been added to our database. Yeah, and I think that's pretty much it. And with regards to the ORM, so the ORM is essentially the same thing as the DIE. So you can implement your own ORM model. That's what we did. Yeah, which is guided by this data access interface. And I think that's it from me.
Thank you very much.
All right, thank you so much, Rahman. Is there anything else anyone else would like to mention before we close this off?
Mm,
Not
I
from me.
think we're all good. Yeah.
All right, thank you so much for meeting up and making this possible. Yeah, let's keep being the awesome people that we are. I'm gonna end the
Yeah.
recording now. Yeah,
Yeah,
No
thank you. Yeah,
problem.
please do.
please stay on the call. Please stay on the call. I just wanna say a few things.
Okay.